This video is talking about the transformation called translation. Translation is another word for slide. It's when you slide something, so up, right, down, left, it's just sliding it around. Translations have a change in position. Because if you're sliding it, it's moving its location. Position is another word for location. For translations, there is no change in orientation. Because as you slide it, everything's still pointing in the same direction. So if I use my hand as an example, my fingers are still pointing up and my thumb is still pointing to the left. So no change in orientation. Translations also, since when we move them, it's not changing size and it's not changing the shape, then the figures are isometric, which means that they are congruent. Same size, same shape. That means congruent. Going over to the description. The description is how we describe things in words. So in order to do translations, in a coordinate plane, we're going to add or subtract values. But we're going to be doing it in a coordinate plane, so we're going to have coordinates. So we're going to do from the x, y coordinates. That's how we're going to move things. The x's on a coordinate plane, so x's actually go left and right. So if we want to go to the right-hand side, we'll actually add to the x's. If we want to go left, we'll subtract from the x's. So left and right, we'll focus on the x's. You might also see another fancy terminology. Instead of saying it wants to go left or it wants to go right, and you cannot do both at the same time. You can go right or you can go left, but you cannot do left and right at the same time. So the fancy terminology that you might see for translating left or right is called a horizontal component. That's the fancy terminology of saying, I want to go left, I want to go right. Horizontal means left and right. To go up and down, we're going to focus on the y values. The y's will go up and down. In order to go up, we need to add a value to our y's. To go down, we need to subtract a value from our y's. So again, you cannot go up and down at the same time. You can go up or down or neither, but you cannot say up and down. Now again, you also have a fancy terminology for up and down. So if left and right was horizontal component, the fancy terminology for the y's will be the vertical component. So it might say you want to have a horizontal component of 5. That means it's left or right horizontal, and it was a positive 5. So that means you would add 5. That means you're going to go right 5. It said vertical component of -2. That would be vertical, so it would be up and down. Negative would be a subtraction, so you would actually go down 2. Going on to the algebraically. Algebraically is actually our mapping rule. And this is the rule that you will always need to know, the rules, mapping rules. Mapping rules, because it's functions, it's function notation, we're going to be using x, y, which is our pre-image coordinate, and we're going to transform it into our image coordinate. So it's going to map to our image coordinate. Now what this is doing is asking, how are we transforming the pre-image coordinate to become our new image coordinate? So what we do is we take our coordinate, whatever our x coordinate is, and we're going to change it by adding or subtracting some number. We're going to add or subtract some number. Now, this will change. Every time you do a problem, this has to change. It has to become the number. Then we'll ask, how are the y values changing from our pre-image? So we'll also add or subtract a number. So this is our mapping rule. Again, these plus or minus a number, that actually has to become a number. So you're either adding a number or you're subtracting a number, but it will become a number. So for example, if I ask for the rule for left 3 and up 5, we start our mapping rule with our pre-image coordinate, so x, y. We write out x, y, because that's our pre-image. We don't have to put any numbers in for it because we're just saying this is what's happening to our coordinate. It's going to map to. So we have our x's. Our x's go left and right. So we look up here, it says left 3. So left is subtracting values, so it's going to be x minus 3. We're going to subtract 3 from all of our x values from our pre-image. Comma, we're going to have our y's. Now y's go up and down, so we have up 5 right here. Up is adding, so it's going to be adding 5, and we're going to close our parentheses. This just tells us that it's going left 3 and up 5, because I am going to be subtracting 3 from all the x values, which means it's going to go that way, left. We're going to add 5 to all of our y values, which makes it go up. So again, these have to actually be numbers. You can't just leave it as plus or minus a number. You actually need to say what number it is, because that's what's happening to the pre-image. Now for a graphically representation, we're going to talk about graphing them and see how we can use our rules. I'm going to first give the pre-image coordinates. I'm going to use a triangle. Coordinate A is at 3, 4. Point B is at 1, 2. And point C is at 4, 0. So I look at my graph. I see I have an x and a y, and I do have a scale on here, so I know that I can go ahead and graph our points. I'm going to graph 3, 4. So 3, 4. And I have to label it as A. You do need to make sure you label the letters, label the coordinates. B is at 1, 2. So I'm going to label this as B. And then C is at 4, 0. I'm going to label this as C. Now, you can have multiple different types of rules here. So I'm going to ask, if I give the image coordinates, I'm going to ask what the rule is. So I'm going to give the image coordinates of A prime is at coordinate 1, 5. B prime is at coordinate negative 1, 3. And C prime is at coordinate 2, 1. Now I want to go ahead and graph these and label them. So A prime is at 1, 5. Label it as A prime. B prime is at negative 1, positive 3. B prime. And C prime is at 2, positive 1. So C prime. Go ahead and connect them. And as you can see this picture, you can see that the black was the pre-image, the pink is the image, so it's been moved. All it is moving to the in a certain direction, and it's pointing in the same direction. Your C's are still down here, your B's are on the side, and A's are up on the top, so it's still pointing in the same direction, but they are in a different position. So the question might be asking, what is the rule? If I ask, what is the rule? So in words, it's important to know the words so that you can easily determine the rule for it. So words, how did we get from A to A prime? So from A, you had to go left 2 spots and then up 1. Do we do the same thing from B to B prime? So left 2 and up 1. Left 2 and up 1. So in words, we went left 2 and up 1. So that's in words. So the mapping rule would have the x, y from our pre-image coordinate maps to, so what do we do to all the x's, what do we do to all the y's? For our x's, x's go left and right. We went left 2, so that's a subtraction of 2, comma. Our y's, we went up 1, so that's an addition of 1. We can actually look back at our coordinates. So if we look at our pre-image coordinates, so the x's, we subtract 2 from all the x's. So 3 minus 2 is 1. That was on A prime. Look at B. 1 minus 2 is negative 1, which is B prime. And for the C, the x of C, 4 minus 2 is 2, which is on C prime. Then for the y's, we added 1. So 4 plus 1 is 5, 2 plus 1 is 3, and 0 plus 1 is 1. So that means that this is correct, that we did do that mapping rule from the pre-image to the image. The property for translations, this is how you can actually prove you use the properties to prove that a translation has occurred. There are properties for all of the transformations, so you prove that property to prove that the transformation has occurred. So the property for translations is that if you connect the points of the pre-image to the image, which means that you'll have segment A to A prime, segment B to B prime, and segment C to C prime. That's what that means by connecting the points. Those lines that you have, the lines are parallel, that's the symbol for parallel, and congruent, that's the symbol for congruent. So just to check this, we can actually prove that this is a translation, that this happened. If we go from A to A prime, B to B prime, and C to C prime, all of these have to be the same distance away from each other, and they have to be parallel to each other. So that means our slopes are the same. So we would use slope to determine parallel, and we'd use distance formula to prove congruent. So for the slope, so from A to A prime, rise over run. We went up 1, left 2, that's 1 over negative 2, so that's negative 1/2. B, up 1, left 2, also negative 1 over 2, so negative 1/2. From C to C prime, up 1, left 2, also negative 1/2, so they are in fact parallel. The A prime, B prime, and C prime are parallel. Now we have to check that they're congruent, the same distance. So you can actually do this using Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared, meaning you can create a right triangle. If you create a right triangle from B to B prime, your leg is 1, your other leg is 2. So this would be 1 squared plus 2 squared. So 1 squared is 1, 2 squared is 4. So 1 plus 4 is 5. That means that the entire length from B to B prime is the square root of 5. If we do A to A prime, we'd have 1 and 2. Again, 1 squared plus 2 squared is 5. So we'd have the square root of 5 as well. From C to C prime, it would be a 1 and 2. So it's 1 squared plus 2 squared. Again, it's 5. So then we'd have the square root of 5. So the slopes on all of these are negative 1 over 2. And the distance from all of these are the square root of 5. So they are in fact parallel, and they are in fact congruent. So that means that this figure, the pre-image to the image, is in fact a translation. So this, again, the property is how you actually prove that that transformation has occurred.